All right, here's your notes for section 2.5. We are going to be doing reasoning using properties from algebra. So we're going to start with reasoning using algebra because algebra is easier for you guys. And you should be able to come through with some reasons for why you do algebra. Plus, you've already passed that class. So we'll start with algebra and we'll work our way up to geometry. In doing these reasons, we are going to work on some properties and some postulates. Do not write all this down. You're going to have a cheat sheet if you don't already. This is cheat sheet number 1. And I would prefer actually that maybe you don't have your cheat sheet out right now and you just listen and follow along and pay attention to what I have going on here and know that it's all written there for you later. 2 postulates that we're going to start with, the segment addition postulate and the angle addition postulate. The segment addition postulate says you've got to have a point, in this case B, which is between A and C. I'm going to move this closer so we can get really clear. If and only if, we've learned that about biconditionals, the measure of AB plus the measure of BC equals the total measure of AC. Remember that those are measures when you don't have a bar over it. So B has to be between A and C, which means if this is A and this is C, B would be somewhere in between. It does not mean that it's in the middle. It just has to be between it somewhere. That means little segment plus little segment equals big segment altogether. Kind of common sense or obvious. If I have 2 segments, little segment, bigger segment, and I put them together, you make one big segment. AB plus BC equals AC. That's all they're saying. Same idea with the angle addition postulate. This time a little different on the wording though. If P is in the interior of angle RST, so you have an angle RST, S is the vertex, then the measure of angle RSP plus the measure of angle PST equals the measure of angle RST. It's the same idea that you're going to take little angle plus little angle, make a big angle out of it. You're going to need a diagram with that just to make it go a little bit better, and perhaps you can draw this on your cheat sheet. If P is in the interior of angle RST, here's RST. P is somewhere in the interior, doesn't matter where, it doesn't have to be in the middle, but P is in the interior, which makes 2 little angles and a bigger angle. It says if you take RSP right here and add it to the measure of angle PST, which is right here, you will get altogether the total angle of angle RST. Again, 2 little angles altogether make a big angle. Common sense, but you've got names for them. Segment addition postulate, angle addition postulate. From there, we're going to go through the algebra part. Those are the 2 geometries that we're working on today. Addition property is anything that can be added to both sides of an equation. You learned this last year. I don't know if you knew that it was called the addition property, sometimes called the addition property of equality. We're not going to say of equality every time. Anything can be added to both sides of an equation. So 2 things are equal. You got A and B. If you add C over here, you better add C over here. Timmy and Johnny are the same height. Timmy grows 2 inches. The only way Johnny can be the same height is if he also grows 2 inches. Add the same thing to both sides of the equation. Subtraction property, same idea. They have to start out as 2 equal properties, 2 equal equations. It's perfectly balanced. If you subtract C from one side, you better subtract C from the other side. Otherwise, one side's going to be heavier than the other. Anything can be subtracted from both sides of an equation. And you can probably guess it. We'll kind of breeze our way through these. Multiplication property, anything can be multiplied to both sides of the equation. And the division property, anything can be divided from both sides of the equation. There is one tiny glitch to the division property, which this is another one of those things that we didn't get too in depth into last year. It was just, hey, here's the division property. But now, as we get more deeper and deeper into your math career, we have to be more careful. Anything can be divided except, of course, 0. You can't take A divided by 0 and B divided by 0. They would both be undefined, which makes them kind of the same, but how can 2 things be the same if they don't exist? So C can't be 0, but otherwise anything you do to A, you would have to also divide on B. The distributive property we should know by now. If you have two numbers being added together, or numbers and variables, and you have the A being multiplied on the outside, you would actually distribute that. The A gets given to the B, and it also gets given to the C. I like the distributive property with chocolate or cookies. If you have cookies and all of us sitting in these parentheses, which would be this class, and you wanted to distribute cookies or chocolate individually wrapped, you could distribute them to everybody in the class. But if you give one to one, you got to give it to everybody. Distributive property. All right, so from there, we are going to go into our actual notes, not from the cheat sheet. So you should have these notes probably on a handout, 2.5, so there's not so much to write. It's going to ask you to solve this equation, and I know it'd be super nice if I could just say, hey, solve this, and then you told me x equals this, and then you're done. Nope. We're practicing reasoning, and we're using algebra so that you don't have too many things to think of at once. Write a reason for each step, but don't write a reason when you show your work. You can show your work, but don't give a reason for it. It's the answer, the result of your work that you have a reason for. For example, here's the equation. You actually have a reason for that. What's the reason for this equation? Because they gave it to us. It was given information. From there, we're going to add 3x to both sides. Add 3x. But we don't put a reason for that. It's down here where it says, how did you get 5x plus 5 equals 20? How did we get to that? We used the addition property. And if you just write addition, it's going to be marked wrong because it is wrong. Addition means 2 plus 7 is 9. That's addition. Addition property says whatever you add to one side of the equation, you've got to add to the other side of the equation. Keep the equation balanced. So addition property. Next one. From there, we're now going to minus 5 from both sides, which this time I'm not going to show the work because you don't have to. If you minus 5 from both sides, don't show the work, but we end up with 5x equals 15. Why does 5x equals 15? Because we use the subtraction property. Then from there, you are going to divide by 5. And whether you use a division bar or a division sign doesn't matter, or if you don't show your work at all, you know that x equals 3. How did you get to that result? You used the division property. So this is a logical argument or logical order of how did you get from here to here. There's got to be a reason because you use the addition property, the subtraction property, and the division property. Now recognize some of you could have done that in a different order. You could have done the subtraction property first and taken the negative 5 and subtracted it over here by the 20. You could have done subtraction property by subtracting 2x over by the negative 3x. There's different ways to do it, but you'll end up with the same result. Okay, we'll go ahead and start this one. Solve negative 4 times 11x plus 2 equals 80. Yep. You're going to ask me, do I have to write that down again? Yes, you do. You have to tell me that this is the start of your equation, and the reason for that is because somebody gave it to you. You have given information. If you want to show your work, show your work. If you don't need to, you can just go right to the next step. Negative 44x minus 8 equals 80, and that is the distributive property. Hey, by the way, you do have a cheat sheet, and I expect you to cheat. I want you to spell distributive right. I want you to spell division right. I want you to spell anything that's on a cheat sheet right. If you're not spelling it correctly, normally I don't correct spelling, but I do correct copying. If I give you a cheat sheet, I expect you to cheat, and I expect you to copy it letter for letter how to spell the right answer. So distributive property. Next step, I choose to add 8 to both sides, which leaves me with negative 44x equals 88, and that is by the addition property. divide by negative 44, which gives me negative 2, and that is by the division property. Capitalization, I don't care about. Whether you use capital letters or lowercase, it shouldn't matter. There's an example of that. Okay, next step in the diagram, AB equals CD, the measure of AB, equals the measure of CD. Show that the measure of AC also equals the measure of BD. So we're going to start with AB equals CD. That's the given information. And then from there, you're going to go AB plus BC equals CD plus BC. Go ahead and write that down, or probably already is written for you if you're following notes. AB plus BC equals CD plus BC. How did they get from here to here? It looks like they added BC to this side of the equation. Oh, they added BC to that side of the equation too. So the addition property works with geometry as well as algebra. We added the measure of a segment to both sides of the equation. As long as it's the exact same segment and measure that you're adding to both sides of the equation, it's still an addition property. From there, we're trying to get to this whole idea that AC equals BD. How do I get AC? Well, let's take a look at the diagram. AC is really the combination of these two small segments. I have AB and I have BC. Altogether, AB plus BC, if I put them together, it equals AC. So I can say that. AB plus BC equals AC. What allows me to put together two small segments and make a big segment? Go ahead and cheat if you need to. The segment addition postulate. Two little segments makes a big segment. That is not the addition property. Know the difference between the two. Segment addition postulate. Segment addition postulate takes two little segments and makes a big segment out of it. Then from there they said, well, we want CD plus BC. Well, that's the other half of the equation. We only dealt with this half, AB plus BC. What do we do with this half of the equation? CD plus BC. CD plus BC equals BD. Look at the picture. I'm going to get rid of this. I'll put this in here in red. CD added to BC equals BD altogether. One big segment. You can use the same reason twice. We added two different segments together. Segment addition postulate. Okay, but then from there it gets a little tricky. When we're done, we say AC equals BD. The measure of segment AC equals the measure of segment BD. Here's AC, here's BD. AC and BD, why are they equal to each other? Well, it's because each side of the equations were equal to each other. AB plus BC, CD plus BC, if those were equal to each other, can't I take this AC? If those two pieces are equal, can't I put that in place? I can exchange those out. They're equal. And can't I take BD? What if I take CD plus BC out of that equation and put BD in its place? It's fine because they're equal. What is it called when you replace something that's exactly the same? Well, in sports, if you know volleyball, not basketball, volleyball, this is a symbol for a substitution. In hockey, you usually do full line substitutions. In basketball, you have a substitute waiting at the table. In football, substitute. But they have to be equal. They have to be equal, meaning if you take the quarterback out, you better put a quarterback in his place, hopefully, for him to do any good. If you take the point guard out, more than likely a point guard is going in his place. A substitute teacher, you take a teacher out, you put a teacher. Okay, those usually aren't equal. Let's not pretend that the substitute teachers are equal to the teachers, especially not in my case, right? No, just kidding. But they have to be equal. If two things are equal, you can replace them anywhere you want. That's called the substitution property. Substitution property. Can't spell substitution? No problem, because you get another cheat sheet. Go ahead and flip to page 2 on your cheat sheet. Or maybe don't look at it right now. Substitution property works for numbers, segments, and angles. Numbers, segments, and angles. If two things are equal, A and B are equal, then A can replace B anywhere in the equation or the expression. Anywhere. Like we just did, we had two equal things. A segment is equal to two smaller segments. We took the two smaller segments out and put another segment in its place. As long as they're two equal things. Substitution property. Works for segments, works for angles. Let's keep going through the cheat sheet before we do another example. Reflexive property. Numbers. This seems really dumb. You're like, of course A equals A, if you can see that, but you've got a cheat sheet. It's really small in here. Of course A equals A. They're exactly the same. Or you could use it for segments and angles. You could say segment BD equals segment BD. You could say angle Q equals angle Q. Any two things are equal to itself. And you might think, why would we ever call that the reflexive property? When would we ever use it? How would we possibly need it? And there is going to be a time, if we talk about these two triangles, not those two. Those are not the same size. If we talk about these two triangles, this left half of the triangle and that right half of the triangle, and you say this segment is congruent to this segment in red is congruent to this segment in blue, where's the third segment that's congruent to each other? You might want to say this red segment is congruent to this blue segment. So there would be an example where you say a segment is congruent to a segment because you're going to use the same thing twice. So you might need the reflexive property. Next one is symmetric property. Sometimes used, not too often, but is it okay if two things are equal, if A equals B? Then can you take B and set it equal to A? Absolutely. You can just take A equals B, flip it around, and make it B equals A. The order matters if you're talking about symmetric property. Works for segments and angles too. If angle A is congruent or equal to angle C, you can say angle C is congruent or equal to angle A. Last one, the transitive property. Let me see if I can't make this a little bit bigger. I would be able to, except for it's. There we go. If A equals B and B equals C, then obviously A and C have to be equal also, even though they didn't tell us that. Here's an if-then statement, conditional statement. We did that in section 2.2. If this is true, hypothesis, conclusion, then this is true. If Zoe is the same age as Joey, and Joey is the same age as Chloe, then aren't Zoe and Chloe the same age also, without me telling you that? She's the same age as Joey. Joey's the same age as Chloe. Zoe and Chloe, in conclusion, must also be the same age. I have $5. Jason has $5. Jason and, I can't think of anything that rhymes with Jason. Jason and Stacy each have $5. Well, then I have $5 the same as Stacy. It all matches together. That's called the transitive property. And it works with segments, angles, or just plain old numbers. And you'll see in a couple of examples how we use it. Let's take this. Use the information given to determine whether angle CBD is congruent to angle EBA. It's going to look kind of like the problem that we just did with segments, but now it's going to be angles. Angle 1 is congruent to angle 3. How do I know angle 1 is congruent to angle 3? Oh, these little red marks. That means that was given information. Those arcs mean congruent. So since they put it in the diagram, that was given information. Angle CBD, trace it if you have to. Angle C to B to D is angle 1 plus angle 2. I have two little angles. Altogether I make a big angle. That's the angle addition postulate. Two little angles make a big angle. That's the angle addition postulate. But so does angle EBA. If I trace angle E to B to A, that's a combination of little angles 2 and 3. A little angle 3 and a little angle 2, when added together, make a big angle EBA, another angle addition postulate. We're just giving some reasons for why this possibly could happen. Now, if you're paying attention at all to what we did with segments, what do we do after that? How do we make these all work out? This one's a little bit different because they share the measure of angle 2 right here in the middle. I'm going to take EBA, or angle EBA. Look at EBA up here. It says angle 3 and angle 2. Right here it says angle 1 and angle 2. I took angle 3 out of the picture. Gone. They got hurt. They got hurt, they're out of the game. What can you do? You can replace angle 3 with something that's congruent or equal. 3 is out, 1 goes in. Why can 1 take the place of 3? Because any two things that are equal can replace each other, which is the substitution property. You have to be able to come up with a mathematical, geometrical reason for how did they get this congruent statement. And it normally comes from right above it. If you look at the statement right above it, they're almost exactly the same. Angle, EBA, EBA, congruent, angle 2. The only thing that different is they took out the 3 and they put in a 1. Substitution property. Makes sense. Finish it up. Why does angle CBD? Why is it congruent to angle EBA, which is what they were asking? Why is angle CBD congruent to angle EBA? Because CBD was congruent to 1 and 2. 1 and 2 is congruent to EBA. CBD is then therefore congruent to EBA. If Zoe is the same as Joey, and Joey is the same as Chloe, then Zoe and Joey have to be congruent to each other. Sorry if that's more confusing because all the words rhyme. But if part A is congruent to part B, and then down here part B is also congruent to part C, then isn't it true that A and C have to be congruent to each other? Go find that in your cheat sheet. You don't have to memorize these yet. You find them in your cheat sheet. That is the transitive property. Can you come up with a reason of why those statements are true? All right, I realize this is getting a little bit long. We're going to finish up this last page. Name the property of equality that the statement illustrates. If the measure of angle 6 is equal to the measure of angle 7, then the measure of angle 7 equals the measure of angle 6. Remember, we use equals anytime there's an M for measure. Go find that on your cheat sheet. Write it down. Why can you take 6 and 7 and flip them and make 7 equal to 6? And that is the symmetric property. Of course, you have to write property also. Next, why can you take the measure of segment JK, which is equal to KL, and the measure of segment KL, which equals 12, and then we take this JK and we say, well, JK is 12 also, because KL and 12 are equal. Those are two equal things. So if I want to take KL out of the game, kick them out, I can put something in its place as long as it's equal. It is definitely equal. If you are replacing an equal piece, then this becomes the substitution property. And you might wonder, before I go on, you might wonder, like, couldn't it be the transitive property? Zoe, Chloe, Joey? Okay, maybe, but Normally in the transitive property, you would have segment, 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 or angle, 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 or number, 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 number. In this case, we're mixing measures of segments with what they're equal to. So basically, we're just taking this 12, putting it in place of the KL, and calling it substitution. Last one, why is the measure of angle W equal to the measure of angle W? Or we could have actually written it as why is angle W congruent to angle W? If you use equals, use an M. If you don't, use congruent. Why is anything equal to itself? Would you please look at your cheat sheet? Let me pause this a second. Hang on. All right, I'm back. We were almost done. Why is anything equal to itself? As I was saying, please use your cheat sheet and look this up. It is not the reflective property. It's the reflexive property that looks like an R. Reflexive property. It's reflexive. Anything is equal to itself or anything is congruent to itself. That's the kind of stuff you're going to have to do on your homework assignment. So please use your cheat sheets as much as you possibly can to spell things correctly, to look things up correctly, and cheat while you can before you have to memorize these, or if you use them enough, you'll accidentally memorize them. But go from there, and good luck on your assignment.